Hello, everyone. Welcome to our today's sharing. My name is Yu Song from Performance Testing Team. The objective of today's sharing, you will get the stories why we roll out the Performance Overview data, dashboard and introduce tuning by database time and tuning by color into TiDB. These two methodologies or techniques has been adopted in the industry for decades. For different people, user response time have different meanings. For DBAs, it maybe means the query duration of a SQL processing in the database. For an end user behind an application or a browser, it maybe means all the times take he or she may submit a request from the browser, and the request goes through network to the application server and raise up some SQL requests to the database and get some data back and do some calculation in the application, and then send back the SQL request to database, get some data again, and finally return the result to the user. So the real user response time for this end user, right? This user report the system is very slow. Maybe database is not the things to blame to. You can see only the time marking these two parts marked in green was spent in database, right? The performance bottleneck could be anywhere. So the first thing for database performance tuning is you should learn to identify whether a bottleneck is inside or outside the database. Here is the source of the performance improvement. What's that mean? Before we doing all the analyze, when people talk about performance tuning of database, they may imagine that a lot of effort should be spent on database or infrastructure tuning, like this part in blue, right? And just a little effort should be spent on application architecture, implementation, and deployment, right? But however, to our surprise, we find it's 50-50. The time you spend on choosing the right application architecture and choose the right way to implement and deploy your application is as important as you spend on tuning the database and infrastructure. Here comes the performance metrics map of TiDB. For example, TiDB has a lot of metrics. We measure the latency of get tokens, parse SQL or compile SQL, and we also get a lot of metrics of TiKVs, right? All those metrics help us to reduce the performance tuning time. Let's welcome Anita.
Hello everyone, I'm Anita.
I will show you how did we do the performance analysis before the performance overview was born. Let's take a look. We can see that the PD, TiDB, and the TiKV have a mass amount of monitoring data. So how can we get the key information from such a massive count of data?
Before the performance overview was created, when looking into certain performance issues, I always gather the TiDB critical paths, such as those are listed under KV request type here, together with their corresponding average latency. You can tell that, in my example, the average latency of PDTSO wait duration here is not outstanding. For now. And then I collect related OPS count from the same duration. The PDTSO OPS CMD is up to around 175,000. Multiplying the average latency and the OPS count. Now I got the total latency time. By sorting the total latency time in descending order, now you can finally get a clear view about where your database is spending most of its time. In the slide, which is interesting, that is, it reveals that PDTSO wait duration is actually the top one consumer of database time. You will never conclude this by just looking at the average latency from the previous slide.
let Yui to introduce to us after the performance overview was born, how will we do the performance analysis? Okay, it's time for Yui.
Okay, thanks, Anita. What database time? What's the meaning of it? Database time is the total amount of time TiDB takes to process application requests. It can be calculated in several ways. For example, you can use QPS to times the average query duration to calculate the DB time, or you can use the sum of the time spent on different SQL phrases to get the DB times. For example, when TiDB get a SQL request, it first should get a token and then pass and compile the SQL and then execute it. So the sum of all the time spent all these phrases equals to DB time. And you also can use Chrome QL to get the DB times from Prometheus. Another methodology is tuning by color. Here, we apply this methodology in our performance overview dashboard. We create 3 charts at the top of this dashboard and use different colors to mark the most time spent in the system. We divided DB time into different dimensions. First, we divide it by SQL type, and we calculate the time to spend on select and spend on update or insert or commit statements. So we mark those SQLs. We mark those write-related SQLs in green and mark those read-related SQLs in blue. And when you see other colors, a significant proportion in this chart, you should on the alert, right? There's something abnormal happen in the system. The system is not doing the customer's workload. Another dimension is to divide the DB times by SQL phrase. We should go through the get tokens, pass, compile, and execute SQL write. And we expected the execute time to take significant part in this chart. So we mark other SQL phrases in different unuser-friendly color, right? Like red, pink, or orange. When you see the other colors than green in this chart, you should be on the alert too. And for the most important execution, divided into query requests or TS await. And we mark those query requests about write operation in green and mark those like cop, get, and batch get read operation. And permitted log in red and TS await in dark brown. So when there's a series log contention in the system, large area in this chart is marked in red. So there's something abnormal happened. Here's a summary of what I said in the previous slide. The DB time could be calculated is the sum of the select times, insert time, update time, all these SQL statements. The sum of all these SQL statements equals to DB time, and the time we spend on these 4 phases equals to the DB time. Now let me show you how to find the performance overview dashboard. We can easily deploy a TiDB cluster with TiUp Playground. Here we deploy a cluster with version 6.2.0. And it will show you the necessary information of this cluster, for example, how to connect to this database and the link of its dashboard and the Grafana, it will Prometheus. You can find the performance overview dashboard in both TiDB dashboard and Grafana. You click the link here. We first go to the Grafana. Here shows the name of this cluster, Playground, and you can find the dashboard here, performance overview. Now you can see all those metrics I introduced in the slides. And then, because we think these metrics are very important and is helpful for performance tuning, so we integrate it into TiDB dashboard in the latest release of TiDB the version 6.2.0. We add a tag here named monitoring and shows the same metrics with the same colors here. You see? Now, let me give you examples how these three charts help us reduce the performance tuning time. The first one comes from the small table cache feature testing. It's a performance feature we released in version 6.0 to help us reduce the latency and increase QPS. But however, at the first time we do the performance testing, find that with this feature on and off, there's this feature looks quite different, right? The color is quite different, and with this feature on, we didn't have better performance. We have lower QPS. Why? And here tell me the bottleneck of the system. TS await take a lot of time when we enable this feature. The developer didn't optimize the TS await issues when we enable this feature. So we can easily spot the bottleneck in the system with this free chart. And with performance overview, with this free chart, with those colors, we can easily compare the performance of the same system in two different periods, different time periods. This is the chart of the normal of a healthy system, and the customer told us suddenly one day the system get quite slow, and you can see there's a very noticeable red light here is the fail query. There's a lot of fail query here, and we also can notice that a lot of KV requests in light blue here is COP KV requests. What happened? And after analyze, we find that there's suddenly a lot of auto analyze in the background, and that's the root cause of the performance issues. With these three charts, with those colors, you can easily compare the performance and with a health system and those systems with performance issues, and find the bottleneck of the system. The last example come from this company, and we can see a very colorful picture here, right? The pass and compile operation make up nearly 60% of the DB time. In this case, the users, the clients, try to migrate data from Oracle to TiDB using the with the AWS data migration service. However, this service also use query API to submit SQL, to submit insert statement to TiDB. So we cannot use prepare plan cache feature to reduce this the time spent on pass and compile phases. And the SQL patterns of them is they first begin to start a transaction and do a lot of small insert and then commit the transaction. So we can notice that there's a lot of QPS here, but only very few KV requests here because before the commit was submit, the data will catch in TiDB and batch insert to TiKV with fewer KV requests. Okay, with all those examples, I think you can have the feelings that how these colors and this DB times concept help you to reduce to spot the bottlenecks in the system. And now I will go through the performance overview dashboard in detail with all of you and tell you what's in the dashboard. First is the DB time and SQL execution time overview. That's the free chart I showed you before on the top. And then comes the load profile and resource utilization, such as KPS, request command type between the application and the database, and the database internal TSO and KV request OPS, or the CPU's utilizations. The last part is top-down latency breakdown, contains a comparison of query latency and connection idle duration. Here comes the summary of today's section. We first introduce a top-down approach to find the performance bottleneck of TiDB cluster. And then we share the story why we introduce a performance overview dashboard into TiDB. And then we describe the tuning by database time and tuning by color in detail.
If you want to learn more, scan this barcode and then you can get access to more PinCap training and certification resources.